this video, we are going to discuss on the forward bias operation of PN junction diodes. And in the previous video, we saw the reverse bias operation. So I recommend you to watch this video once again and come back to this video. And you can see this is the potential, or this is the source connected to the PN junction diode. The positive side of the source is connected to the P layer and the negative source side is connected to the N layer, right? So this positive side of the source will now repel the majority charge carriers called the holes, which are marked in the red color, to the N side, right? So the electron hole pair is now created by force. Okay, so the negative side of the source now pushes or repels the electron from the inside, right? So that the electron hole pair is again happening by force, right? So as a result of this, the size of this depletion layer, I'm just marking it in the yellow color, the size of the depletion layer is getting reduced. As far as the reverse bias is concerned, the size of the depletion layer is large, so the contact potential is also large. Now the depletion layer is now shrinking in size, shrinking. It is reduced due to the accumulation of charge in the p type and the n type, right? So since the majority charge carriers call the holes in the p crystal, so it may be perceived that the positive terminal pushes the holes in the p side and electrons are pushed from the inside, so the contact potential is reduced. So the majority charge carriers are now free to move, right? So the majority charge carriers, I'm just writing as an abbreviation here, are moving freely. This gives rise to the diffusion current, right? So the diffusion current can be denoted as ID, right? So it can be noted that the applied voltage in forward bias encourages the flow of majority charge carriers, leading to an increased flow of diffusion current ID, right? So this diffusion current ID can be expressed in the form of an equation with respect to the potential difference. So ID is nothing but I naught. I naught is nothing but the drift current that is happening because of the applied EMF, right? Q Vd and Kt divided by Kt, right? So what is this exponential growth, right? So we have seen this before. Q is nothing but the charge of an electron, 10 to the raised to the power 19 coulombs, right? So Vd is nothing but the potential difference across the junction in volts. So the potential difference across the junction is mentioned in terms of volts, and K is a constant. So K is nothing but Boltzmann's constant. So K is 1.38 multiplied by 10 raised to the power minus 23 joule per Kelvin. So I'm sorry, Kelvin per joule. It's been written as Kelvin per joule. It is actually joule per Kelvin, and the temperature here is in Kelvin, right? So the net diode current. So what is that diode current? We can go back to this circuit, small circuit diagram here. So this is the positive and negative terminals of this source, right? So diode current flows in this direction, right? So this diode current can be expressed like this. So diode current is nothing but ID, I small d, diffusion current minus the drift current. And you know what is that diffusion current, right? From this equation you can find out, you can rewrite that expression for ID. So e power q Vd divided by Kt minus I naught. So you can take I naught as a common term outside. So it is QVd divided by Kt minus 1, right? So this is the formula for calculating ID, diode current, for a PN junction diode in forward bias conditions, right? This I naught drift current will be in the order of 10 power minus 9 to 10 power minus 15, and it is a very small amount and can be ignored sometimes, right? So in that case, this equation takes a different shape, right? If they ask you what is the formula for diode current in the p-n junction diode in the reverse bias forward bias conditions, you can write down this expression. All right, so this narrowing down of depletion layer along with a small potential barrier, right, creates a low resistive path, right? The depletion zone is getting shrinking and it is creating a low resistance path. Low resistance path. So this word is very important as far as your exams are concerned, right? Low resistance path is created, and because of this low resistance path, the low barrier voltage, right, and because of these two phenomena, this diode is now acting as a conductor. This is all about the forward biasing of a p-n junction diode. If you have any doubts, you can put it in the comment section, or you can suggest any other video you want to see in our channel. Thanks for watching.